In this video, we will learn how to determine whether two events are independent events and how to apply the multiplication rule for independent events. Statista Motors builds two models of cars, the Regressa and the Devion. 70% of the company's customers purchase the Regressa and 30% purchase the Devion. Floor mats are standard equipment. Customers must select between two different styles, the all-weather mats and the no-weather mats. Previous experience shows that both styles are equally likely to be selected, regardless of the vehicle that was purchased. If a customer is selected at random, find the probability that a Regressa with all-weather floor mats was purchased. Two events, A and B, are independent events if the fact that A occurs does not affect the probability of B occurring. We are told that both types of mats are equally likely to be selected regardless of which model is purchased, so the probability that an all-weather mat would be selected is 0.5. This also means that the conditional probability, the probability that all-weather mats would be selected, given the customer purchased a Regressa, is also equal to 0.5. Likewise, the probability that all-weather mats would be selected, given the customer purchased a Devion, is also equal to 0.5. These probabilities being equal shows the independence between the vehicle model choice and the type of floor mat choice. When two events A and B are independent, the probability that both events A and B will occur is equal to the probability that event A will occur times the probability that event B will occur. This concept is frequently illustrated using a probability tree. When a vehicle is purchased, the Statista Motors customer must first choose between a Regressa and a Devion. Once the vehicle is chosen, the customer must choose between the all-weather floor mats and the no-weather floor mats. He must make this choice whether he purchases a Regressa or a Devion. Now, let's assign probabilities to each branch of the tree. We are told that 70% of the vehicles sold by the company are Regressa models, so the probability that a randomly selected customer purchases a Regressa is 0.7. Now, using the concept of the complementary probability, the probability that the customer would purchase a Devion is 0.3. Since floor mat choice is independent of vehicle model selection, and both floor mat types are equally likely to be selected, the probabilities along each branch in this part of the tree would be 0.5. Now, let's assign symbols to represent events. This will simplify the process of expressing probabilities. We can let R represent the event that a Regressa is purchased. D can represent the event that a Devion is purchased. A can represent the event that all-weather mats are chosen. And N can represent the event that no-weather mats are chosen. The original question was, if a customer is selected at random, find the probability that a Regressa with all-weather floor mats was purchased. Recall that for independent events A and B, the probability that both events A and B will occur is equal to the product of the probabilities that each will occur. The probability that a Regressa with all-weather floor mats was purchased would be expressed in probability notation as the probability that both events R and A will occur, which is found by multiplying the probability that event R will occur by the probability that event A will occur. Notice that this is basically the top branch of the tree. So we have 0.7 times 0.5 for a total probability of 0.35. So the probability for the top branch of this probability tree is 0.35. Now let's find the probability that a randomly selected customer would purchase a Regressa with no weather mats. In probability notation, we have the probability that both events R and N will occur, equal to the probability that event R will occur times the probability that event N will occur. This would be then 0.7 times 0.5 equal to 0.35 again. So the next branch down would also have a probability of 0.35. Continuing this way, We have the probability that a customer will purchase a Devion with all-weather mats equal to 0.15, and the probability that a Devion with no weather mats will be purchased is also 0.15. The sum of all the branch probabilities will always be equal to 1. This makes sense since a customer of Statista Motors is certain to follow one of these sequences of events. In this video, we learned how to determine whether two events are independent events and how to apply the multiplication rule for independent events.